we are deeply, deeply honored and privileged to be here with Professor Michio Kaku. He is an absolute living legend. And people like myself, I'm a little futurist, and in the presence of a great futurist, a physicist, a visionary, an author of multiple books, and a man who is constantly challenging the status quo and visualizing the future. Very few people have the courage to do that, and more importantly, very few people, very few scientists in the world have the ability to take this knowledge and get it out to us through media, through various other new digital technologies. And Professor Kaku-san is exactly one of these people, and we are honored to have him here today in Dubai, and we look forward to this conversation to go deeper into his thoughts and how he sees the future. Professor, it's a real pleasure. Thank you very much being here, and honor to be here with you. Thank you, sir. Mm-hmm. We hear a lot about you talking about the future of the mind, the future of physics, and so on. But before we go there, can we talk about you, Michio-san? How did your early life start? I mean, what was your background? And we want to sort of humanize your starting point.
Well, it all started when I was 8 years old. When I was 8 years old, everyone was talking about the fact that a great scientist had just died, and I'll never forget the picture they put in the newspaper that evening. The picture was a picture of his desk, that's all, with a book. And the caption said, "This is the unfinished manuscript of the greatest scientist of our time." So I said to myself, now wait a minute, why couldn't he finish it? What's so hard that the greatest scientist of our time couldn't finish this book? So I had to know. This to me was more intriguing than in any murder mystery. This was more interesting than any adventure story. I had to know what was in that book. Well, I went to the library and I found out the man's name was Albert Einstein. That book was the theory of everything. An equation that was to be no more than perhaps 1 inch long that would allow him to read the mind of God. So I said to myself, wow, that's for me. That's what I want to work on. And in fact, that's what I do. We think that string theory is the leading and only candidate for a theory of everything. And I'm one of the creators, early creators of the theory. And so we're trying to test the theory. We don't have the machines that can do that yet, but already we have the Large Hadron Collider. It found the Higgs boson, which is also part of string theory. So we think that we're onto something. This could be, in fact, the theory of everything.
Were there any teachers in your early life, any other than the inspiration with Einstein, who shaped you into who you are today?
Well, actually, when I was 8 years old, I used to always watch television on the weekends. And on Saturday morning, they had Flash Gordon. And Flash Gordon, to me, was better than any teacher, because he made physics exciting. Yeah. All of a sudden, physics had an application. It was the physicists in Flash Gordon who made it work. Right. They're the ones who built the Starship. They're the ones who built the invisibility shield. They created a city in the sky. And another young kid my age was George Lucas. He also watched the very same series, and he said, I want to make a movie, a modern movie about it, and he created Star Wars. So Star Wars is a direct clone of the early Flash Gordon series.
Interesting, didn't know this.
Yeah, so in some sense, Flash Gordon was my teacher. He showed that physics could be exciting, that with physics you can do something. You can dream about starships. You can talk about ray guns. It's just not psychobabble. We're talking about real equations and real hardware coming out of physics.
Tell us about your parents, your mom and dad. You originally come from Japan, I believe, or your parents do. Tell us about their life and how that sort of impacted you in the early days before we go into the future.
Well, my father was a gardener, and during the war, World War II in California, they were U.S. citizens, by the way. My father and mother were born in California, but they were locked up from 1942 to 1946. I was born afterwards, and I realized that if I was going to amount to anything at all, I was going to have to do something. So when I was in high school, I went to my mom one day, and I said, Mom, can I have permission to build an atom smasher in the garage? A 2.3 million electron volt betatron particle accelerator, to be exact. And my mom stared at me and said, sure, why not? And don't forget to take out the garbage. So I took out the garbage. I went to Westinghouse. I got 400 pounds of transformer steel, 22 miles of copper wire from Baron Associates. And over Christmas, on the high school football field, I wound the magnets for my particle accelerator. It consumed 6 kilowatts of power, drained the entire house electrical circuit. Every time I plugged it in, I would hear this pop, pop, pop sound as I blew out every single circuit breaker in the house, every single fuse I would blow out. And my poor mom, you know, she would come home from a hard day's work and saying, uh-oh, the lights are out. Where's the fuse box? Get the fuse box. And she must have thought to herself, why couldn't I have a son who plays baseball? Maybe if I buy him a basketball. And for God's sake, why can't he find a nice Japanese girlfriend? Why does he have to build these machines in the garage? Yeah. But, you know, it paid off. I went to the National Science Fair, and I met a physicist who actually helped my career. His name was Edward Teller, father of the hydrogen bomb.
Yes.
And so almost immediately, I began to meet the people who design hydrogen warheads, but also design the future. Right. These are the people who built the laser, the transistor. These are the people who created the architecture for today's high-tech world.
And that was your opening into going to university and then literally starting your career as a gardener's son, going into university and taking out from there. So you got a scholarship at Harvard?
That's right. And so Edward Teller, the father of the hydrogen bomb, was part of a scholarship program. So he would pick out the brightest young kids and give them scholarships. So that's how I started my career.
Yeah. Now, fast forward into today, what was your journey over the last 30, 40 years in terms of navigating through governments, through difficulty in getting grants, through making science sexy, and then moving forward with that? I mean, what were the kind of resistance and things that you were facing throughout your life?
Well, I had a role model, and I studied the life of Albert Einstein, and I realized that, first of all, he was a theoretician, not an experimentalist. He did not have to have huge government grants to build gigantic machines as an experimentalist. He was a theorist. He would think about pure mathematics, and from the mathematics, he would extract physical principles. And so I said to myself, that's the way I want to do it, because there are no roadblocks. The playing field is level. You don't have to have a big grant. It's just you and that sheet of paper and whether or not you can come up with new ideas, new mathematics, and new techniques. Now today, when I go around the world lecturing and stuff like that, I'm not wedded to my experiment. I don't have to run home every time the vacuum pump breaks. So that's one thing I learned from Einstein, that if you're a theoretician, your mind is your laboratory. Your pen is your laboratory. You can go as fast and as far as you want. The only limitation is the power of your mind.
You mentioned the 4 stages, and we are at the 4th stage. Can you, in your words, explain what those stages are?
The first stage that we physicists worked out was the stage of mechanics. We worked out Newtonian mechanics, machines. We created the heat engine with thermodynamics, and boom, that started the Industrial Revolution. Right. The Industrial Revolution owes its origin to Newton's laws of motion and the laws of heat that we physicists worked out. So we went from an agrarian peasant society to a modern day machine age society. Then we worked out the laws of electricity and magnetism. We created motors, generators, TV, radio, microwaves. That was the second great revolution. The third great revolution was when we physicists worked out the quantum theory of transistors, the quantum theory of lasers, and that gave us the high-tech world of today. And now we physicists are working on the 4th wave of wealth generation. Artificial intelligence, nanotechnology, and biotechnology. These are going to be the drivers of wealth generation into the future.
You're celebrating physicists and you're giving them a lot of credit. So, as a physicist, how do you see the future of physics?
Well, see, we physicists try to look at the fundamentals, and we want to know what happens once we unlock the fundamentals. For example, life. Life was a big mystery ever since we first looked at the animal kingdom and plants. What is life? Where does it come from? But quantum physicists in the 1920s and 30s said we have to apply atomic theory to life. There must be a molecule that encodes the secret of life. Well, believe it or not, Francis Crick read the book, What is Life? By Erwin Schrödinger, a quantum physicist, and he said, I want to find that molecule. And we did. That molecule is the DNA molecule, and it was physicists who logged onto it and sequenced it and made possible the biotech revolution. And so we realized that physics is more than just atoms. It's looking at the fundamentals that drive the universe.
Let's go into humanity, and you also talk about how humanity is now shaping. What is your view in terms of where humanity is going? And then I have a follow-on question which will be a bit more penetrating.
Well, first of all, some people say, woe is me, the world is going to hell. I don't look at it that way at all. I think the smallest unit of history is the decade. Anything smaller than a decade, you get random fluctuations. And when you look at decade by decade, you see the enormous progress that science has made. In the year 1900, for example, the average life expectancy in the United States was 49 years of age. 49 years of age, and that was in the United States. Throughout the world, it was around 35. And that's what life expectancy was for many a century. You have to go back. When you go back to the time of the Romans, in fact, life expectancy during the Roman Empire was about 30 years of age. And so people didn't live very long, and they lived horrible lives, lives with tremendous amount of wear and tear on their bones and their health. So it was not very pleasant. What happened was science happened. That changed everything. All of a sudden, with medicine, we can cure many of these ancient diseases. We didn't have to break our bones anymore because we had machines and mechanical devices that could industrialize modern society. So science made the difference. But you see, most people don't know that. Most people think that, well, it comes from the sky. I mean, wealth, it grows on trees, right? That's where wealth comes from. You want an iPad, an iPhone? Well, you just go to the store and buy it. That's where food comes from, the supermarket. No, it comes from science and technology. And just remember that many nations don't understand this, that commodity capital, like for example food has been getting cheaper and cheaper for the last 200 years because we're making a transition from commodity capital, like food, to intellectual capital like science, computers, and high technology. And so nations of the future that only invest in food and agriculture, they will be poor in the future. I'll make a prediction. Yeah. Those countries which only invest in agriculture and commodities will be poor in the future. Those countries that use commodities to leverage their way into intellectual capital, capital of the mind, yeah, they will be rich in the future. As Tony Blair of England likes to say, England derives more revenue from rock and roll than the coal mining industry. Now, when you think of a British worker, you think of a coal miner. But coal gets cheaper every year, while rock and roll, you can't mass produce the Beatles. You can't mass produce rock music. No, that's intellectual capital. And so the world is making this transition, and countries that understand it will be rich. Countries that only get stuck in agriculture will be poor.
You know, you speak about humanity and you speak about us, our life expectancy growing. Can we take it to the extreme and talk about immortality?
Yes, we physicists have seriously looked at the physics of immortality. there's two ways to become immortal: biological immortality and digital immortality. For example, it's possible to digitize everything known about you. Your credit card transactions, your Instagram photographs, your emails. There's a company in Silicon Valley that already, for money, will digitize everything known about you. In the future, when you go to the library, instead of taking a book out about Winston Churchill, you'll talk to Winston Churchill. We will digitize him. You'll talk to a holographic image that has all his mannerisms, all his speeches. I would love to talk to Einstein. I would love to talk to a digitized version of Albert Einstein. All his speeches, his theories digitized. And one day, you and me, we may be digitized too. We may be able to talk to our great-great-great-great-great-great-grandkids, and they may be able to talk to us because we're immortal. We're digitized. And this is well within the range of progress of today. Now we're working at the pathways of the brain as well. Memories, emotions, feelings, those will be digitized because we're now beginning to map the entire human brain.
You mentioned about the human brain, and we'll get to that. My issue on immortality is another. One of them, obviously, is the digital version. And medical science now is going towards digital twins, digi-twins. So you and I can, at the genome level, create a digi-twin. So when we want to experiment on my body, I will experiment on the digi-twin rather than actually the physical body. So that's the biological twin. And then obviously the digital, digital twin. But is it all about memories and soul and consciousness and spirit around which is being captured rather than just our credit card details and history?
Well, first of all, we can now record memories.
Yes.
This was only done a few years ago. In mice, we've been able to record the impulses across the hippocampus where memories are first processed. We can tape record that. You play it back later, and mice will remember what they forgot.
Yeah.
Now we're doing it with monkeys. Next will be Alzheimer's patients. Alzheimer's patients will have a memory chip. You push a button, and memories will come flooding into your mind. And who knows, in the future, maybe when you go to college, you'll push a button and learn calculus, or you learn physics just by pushing a button. Now, of course, we're not there yet.
Yeah.
But the point is that this could be the future of the internet. The internet today is digital, but the future of the internet could be BrainNet. That is, we'll be sending memories, feelings, emotions on the internet. Teenagers will love it, because teenagers already put a happy face at the end of every sentence. Why bother? Why not put the emotion? Why not put the memory after the end of every sentence?
So is that the future of the brain, that we'll be able to telepathically talk to each other? And
Telepathy, telekinesis, recording memories, printing out pictures. We can now photograph dreams. You know that?
Yes.
We can actually photograph dreams now by MRI scanning the brain into 30,000 pixels and then having a software program that takes 30,000 dots, measuring blood flow, and recreates a photograph of what you are thinking.
so the blood flow in the brain is being mapped. So can we see different people at different stages in their lives, if they are children, how the blood flow is moving, meeting a beautiful girl, as you once mentioned, where the blood flow happens, and what kind of behaviors do we have?
Yes, we can now actually see how thinking takes place moment by moment by looking at blood flow. For example, this was an experiment done at the college where you have a man that looks at a picture of a pretty girl, okay? And we all know what happens. The man starts to act mentally retarded. He starts to stumble over words and, can't remember anything talking to a pretty girl. Well, we have brain scanned these people, and we find that blood drains from the prefrontal cortex when they talk to a pretty girl, and that's why they act mentally retarded. We actually have a physical basis. We can quantify this effect. We can give it a number as to how retarded you are when you talk to a pretty woman, because you get all tongue-tied. And we see this at the level of blood flow in the brain.
I met a top neurosurgeon, Dr. Brown, in the US, and he said that our bodies are now living longer, but our mind is sort of fading away at 80, 90 years of age. And he said in 20, 30, 40 years' time, this was about 4 years ago, we will be physically strong, but our minds won't be there. After reading your work, I found it extremely encouraging that the mind can remain sharp and can be extended and memories can connect. My mother is in the first stages of dementia and then they're saying potentially Alzheimer's. Now, would those memories start coming back? Would we be able to create something that actually extends life for humanity as opposed to just being a physical robotic vegetable?
Well, let's talk a little bit about biological immortality as it affects the brain and the human body. Where does aging take place in a car? Cars age, but where does aging take place in a car? It's the engine.
Yeah.
Why? You have moving parts and you have combustion. Now, a cell is like a car. Where do we have moving parts? Where do we have combustion inside the cell? The mitochondria. Bingo. We now know more or less where aging takes place, and that is at the cellular level. So we now know more or less what aging is. Aging is the buildup of error. Error at the genetic level, error at the cellular level. Cells get sluggish. They start to work inefficiently because errors build up in their instructions and they don't carry it out. But now we have CRISPR technology, the ability to edit almost like we edit manuscripts.
Yeah.
Edit DNA, cutting it and splicing it at certain points. And maybe we'll be able to eliminate some of the mistakes that build up in the mitochondria of the cell. That may give us a handle on immortality. For example, animals live to be different ages. The Greenland shark lives to be over 400 years of age. We know that because they add another layer in their eye every year, and by analyzing the eye of the Greenland shark, we count the layers, and bingo, they live over 400 years of age. And so there's no reason why we can't do it. They're made out of the same DNA that we're made out of. And so one day I think we'll be able to correct the errors that build up and then reverse the aging process.
This brings us to a nice segue into probably the most important thing to me in all of this science and growth, and that is the issue of ethics and values and trust and empathy and the pillars on which our future can reside. You spoke about CRISPR. CRISPR can be used for good, exactly in terms of the way you mentioned, or it can be used to create, master races and robotics and so on. So where I'm going with this is we have so much power through science and physics. With great power comes huge responsibility. And it's everybody's responsibility. What are we doing, sir, as a humanity, as a species, as governments, as intellectuals like yourself? What are we doing to understand ethics? Because we can have science, but if we don't have ethics, we will lose our way.
I would disagree with most scientists on this point. Most scientists would say that science is neutral, that science is a double-edged sword. One side of the sword can cut against people, cut against innocent people. The other side of the sword can liberate innocent people. But I would tend to disagree. I think that technology does have a moral direction because the spreading of the internet spreads information. Information leads to empowerment. People say to themselves, I don't have to live under this dictatorship. Why do we have to be poor? We can be rich. I can start a company. Look, it's all on the internet, right? So with the spreading of knowledge spreads democracy. And democracies do not war with other democracies. I mean, think about all the wars we had to learn going back thousands of years. They've always been between kings, queens, emperors, never between two major democracies. And so I think that science and technology does have a direction. Now, the question is, in the future, when we have this tremendous power, will we also have the wisdom of Solomon to go with this tremendous power? And that's where I think democratic debate comes in the picture. Democracy is slow, it's not the most efficient, but at least everybody gets on board, you see. And so I think technology does have a direction.
Okay, I will, with respect, comment that technology in the wrong hands, and a lot of this thing is happening at the moment in terms of robotics and, robots being weaponized, and various other genetic things that are going on. At the moment, there is no real control or in terms of how data and how technology is exploding. And I use the word exploding because by definition it's just going out there. My question, peeling the onion a little bit more, is that in this process, what do we need to do as human beings to learn about, let's say, ethics and values? Is that at school? Is that, how does that come about? Because I'm still grappling with that.
Okay, well, you mentioned robotics several times, so let's just jump right into it,
Sure.
okay? First of all, we have been brainwashed by Hollywood to think that right around the corner, they're going to be Terminator robots who are going to take over. We're all going to be put inside cages, and our robots are going to throw peanuts at us and make us dance behind bars like we make bears dance behind bars today. We're going to be the monkeys and the bears of the future, right? But you see, that doesn't conform to the actual state of artificial intelligence. If you compare our most advanced robot to an animal, what animal would it be? It would be a cockroach, a retarded cockroach, a lobotomized, retarded cockroach. Our most advanced robot can barely walk across the room, can barely recognize things, can barely pick up objects very, very slowly. And a cockroach can run around, find mates, find food, disguise themselves, camouflage. Our most advanced robots can't do that. Now, in the coming years or so, robots, of course, will be eventually as smart as a mouse, then as smart as a rat, then as smart as a rabbit, then a cat and a dog, and I think maybe by the end of this century, as smart as a monkey. Now, monkeys are self-aware. They know they're not human. They are potentially dangerous. So I think we should put a chip in their brain to shut them off once they have murderous thoughts. Now, dogs, on the other hand, dogs are confused.
Yes.
Dogs think that we are a dog. We're the top dog, they're the underdog. That's why they obey us, okay? But you see, monkeys, they know they're not human. So once our robots become as smart as a monkey and have self-awareness, then we have to worry. But that's not going to be for 100 years.
Okay. A couple of important things to wrap up on. The first one would be education. As I mentioned to you earlier, it's very close to my heart, and I go beyond education. I go for learning, and learning how to learn, and learning how thinking works, and metacognition, all of those things. Our education system globally sucks. It's not getting us ready for the future. I'm giving an opinion, but what are your thoughts in terms of where education is going and what do we need to learn?
Well, education is the key. Now, when we're born scientists. Yeah. We're born wondering why the sun shines. We want to know where we came from. Yeah. We want to know why the stars twinkle. And when we're about the age of 10, we have this epiphany, this existential shock, realizing how glorious and how great this universe is. That's what starts many people on the trek to become a scientist. But then we hit the greatest killer of scientists known to science, the greatest destroyer of scientists known to science, and that is when you hit junior high school. That is when you start to become 13, 14, 15 years of age. All of a sudden, science is made boring. You have to memorize all these stupid things that you know you're never going to use again. You have to learn the lingo of useless information that is totally irrelevant to your life, okay? And that's when peer pressure kicks in. That's where we have to make sure that we train our kids to realize that science is life. It's about everything around us. It's about wealth generation. It's about health. It's about empowering yourself rather than memorizing the parts of a flower, memorizing the parts of a cell. I mean, who cares? Yeah. In the future, just look it up in a book.
Yeah. And learning is also about play, It's also about images and metaphors and learning through that process as opposed to, like you said, just memorizing things. Now, what is your advice, and we're in a young country, in terms of the kinds of qualifications and degrees that people should have? Maybe not degrees, degrees is a very 19th, 20th century word, but what sort of learnings and developments should we have?
Well, first of all, the jobs of the future will be those jobs that robots cannot do.
Correct.
So the question is, what jobs can't robots do? There are three kinds of jobs that robots cannot do. One is semi-skilled work requiring pattern recognition. Picking up garbage, fixing a broken toilet, sweeping the floor, planting a tree, gardening, police work, finding a criminal. Robots can't do any of the above. Robots cannot pick up garbage. Robots cannot fix a broken toilet. Robots cannot sweep the floor. Semi-skilled work. Number two, interpersonal relations. Robots cannot be lawyers because lawyers have to argue to a jury, have to argue to a judge. They have to understand people's feelings and mores and ethics. Mentors, professors are going to be less and less regurgitating facts, which will simply get in your contact lens. The internet will be in your contact lens. You'll blink and you'll see today's lessons right there, right? But mentoring, career guidance, that kind of stuff, that's what professors are going to do. Grading homework assignments and one-to-one personal interaction. Three, the most important, intellectual capital. That is innovation, leadership, analysis, things that people do who are educated, using their creativity, using their innovative process to create new industries. That is going to be the most important aspect of the robotic age. Robots can't do that. Robots are not innovative. They can't plan. They're not visionaries. That's where humans come in. And of course, robots cannot write novels. They cannot write new songs. They can imitate, but they cannot create new galvanizing songs. So I think that's where we have to emphasize our education, intellectual capital.
Indeed, and when I, as a mentor, sometimes I'm a mentor and I have young mentees, 20-year-old mentors for me. And when they ask me, what kind of degrees do we take in the future? And normally they're going for law, finance, accounting, all this kind of, I say something very similar. But I say astronomy, anthropology, zoology, doing things of that nature. Would you subscribe to, these kinds of directions? Because it's not considered that you'll get a job because you are an astronomer. You teach astronomy. You wouldn't get a job because you're an anthropologist, but now Airbnb and others are hiring anthropologists on a daily basis. This shift is taking place. What do we need to do to catalyze this shift?
Well, believe it or not, many physicists wind up on Wall Street. And the reason is sometimes there's not enough professorships for physicists. And however, they have tremendous mathematical skills that Wall Street love, because that's where algorithms come from. Yeah. That's where fintech comes from, right? So guess who created a lot of the fintech and created a lot of these algorithms? Unemployed physicists, okay? So it's not specifically the major that you have, it's the way of thinking and the training that you get by going into something like that. So in Wall Street, when you tell your interviewer that you're a physics major, they say, wow, that means you can do the real hard math. You can make money for us, right? Yeah. You can write the algorithms and you can do the financial analysis of Wall Street and all the twists and turns using computers. Yeah, that's right, we can do that. Yeah. And so when you major in a subject, it's how you think is what you learn, not necessarily the discipline itself. So that's why physicists who cannot get a job doing physics wind up making more money than me on Wall Street.
Yes. You have a secret, and I think you've just alluded to that, of becoming a billionaire. I know you talk about it. So how do you become a billionaire? Because there are so many aspiring people in this country who want to do just that.
Well, take a look at a corporation, any corporation in any field. you find friction, you find areas of frustration, you find middlemen. And what you have to do is you have to digitize that, okay? Digitize the middlemen, digitize the frustration, digitize the friction of capitalism. Because why is Jeff Bezos the richest man in the world? He's not the smartest man in the world. He's not the most innovative man in the world. No, he saw an industry and he saw that he could digitize the middlemen, the retailers, right? And he realized I could sell directly to the customers. Look at Airbnb, look at Uber, look at all these great startups, right? They started because somebody had a vision, and that is perfect capitalism. You see, what is capitalism? Capitalism is private ownership where prices are set by supply and demand. But you see, capitalism is not perfect. Capitalism is clumsy because there are middlemen, there are layers of friction, aggravation, waste, all of which can be digitized. So when you create perfect capitalism, you eliminate unnecessary levels by digitizing these levels, and that's where you get the next crop of billionaires coming in.
But if you're talking about perfect capitalism and perfect information, by definition, that's the end of capitalism, because there's no friction left. So
no, capitalism is going to thrive because you make money.
What I mean by that is that if I have perfect information, if I pick something like this up and I know exactly what it is, and at the press of a button I can understand all, the comparative analysis and the price and so on. So therefore the friction's gone. You become a frictionless, seamless kind of environment.
That's right. That's what we're headed for. That's the future.
So the capitalism there could be an end of capitalism in our lifetimes.
Not the end, the perfection of capitalism.
I see.
The aggravation, the frustration is going to be eliminated. Remember, supply and demand. People want things. They want convenience. They want services. That's the engine. As long as people want something, somebody will say, I'm going to give them what they want, and I'm going to digitize it to make it faster and simpler. Now, once people don't want things, then capitalism is over. Then it's gone. Right. But, that's a graveyard, right? Yeah. People want things, but there's friction involved in the wanting process. And that's where billionaires have made their money, by removing these layers of inefficiency, digitizing them, and that's how you can become a billionaire.
Last couple of questions, sir. The future of science. What are the top 2 or 3 challenges of science that you visualize, and how close are we in terms of finding real solutions to those problems?
The 2 greatest problems in science is, first of all, what happened at the beginning of time, and second of all, what's happening right on your shoulders. At the beginning of time, we think there was a unified field theory that governed the dynamics of the Big Bang. That's what I work on. That's my day job. That's what I do for a living, working on string theory. But what's on your shoulders? What's on your shoulders is the most complex object in the known universe. There is nothing more complicated than the human brain, with 100 billion neurons, which each neuron is connected to 10,000 other neurons. So that's 100 billion times 10,000. That's an incredible number of connections, and we're clueless as to how to fit the whole thing together. Now, I have my own theory of consciousness, which I put in my book, The Future of the Mind, and I have a theory which is testable, which is reproducible, and it includes animals. I think that even animals can be conscious to a degree. And I think we can actually measure and quantify consciousness.
Can science get us to Mars?
I think so. We're going back to the moon by the end of this year or early next year. After a 50-year gap, we're going back to the moon. And a lot of that is financed not by the taxpayer, but by Silicon Valley billionaires who are opening up their checkbooks and underwriting the cost for a lot of these missions. It's incredible. Who would have thought? A private individual building a moon rocket, right? But that's what's happening now. And by 2030, in that decade, we hope to have the first manned mission to Mars.
Cancer seems to be a scourge of our modern world. We've got so much computing power and genetic changes and understanding of genome. Why aren't we being able to just eliminate it?
Well, you see, before we thought that cancer was like a disease, a normal disease. You find the microbe, kill it, that's it.
Yeah.
End of story, right? No, we now know that cancer is a defect of our cells.
Yeah.
And there are so many ways in which the cells of our body can go defective. That's why cancer is so difficult to cure, because it's a moving target. Every cell has moving parts. There are many ways those moving parts can be defective to create cells which it can reproduce to create cancer. That's why AIDS is so difficult. That's why cancer is so difficult. They're moving targets. So the more we realize about cancer, the more we realize that there are thousands of types of cancer. Any cell has many ways it can go haywire. There's encyclopedias of cancer now. Cancer is just not one disease. It is really us. It's the price we pay for complexity. You know that single-celled animals, you know, little algae and things like that, they don't get cancer.
Yes.
The price we pay for complexity is cancer. Sorry about that.
Well, we're complex, and that's why we are so unique. And the final question, sir, ending on a high and talking about the brain, you talk about the brain net and all our sort of consciousness coming together.
Right. That's the future of the internet.
That's the future of the internet.
Right.
But with these brains, all our memories, can we just have a big, massive brain and, like you say, just shoot it into the galaxies and up there and connect with a bigger level of super consciousness? Now I'm getting into woohoo stuff, but,
no, but
maybe it's not woohoo.
Within the laws of physics, once we digitize the brain, we can put that information on a laser beam and shoot the laser beam to the moon. In 1 second, you're on the moon. Your consciousness can be downloaded on the moon, downloaded into a robot or avatar, and you can then walk on the moon in 1 second. In 20 minutes, you're on Mars. In 8 hours, you're on Pluto. And in 4 years, you're on the nearby stars. I call this laser porting. Laser porting does not require booster rockets. There's no accidents, no weightlessness problems, no micrometeorites, no radiation problems. It's just pure energy in the form of consciousness, the digitization of the brain, shot on a laser beam to the moon, where it's downloaded into an avatar, and you could have breakfast in New York. You could then have brunch on the moon and Mars, and then in the afternoon, journey through the asteroid belt, visit Jupiter, and come back that same night. All at the speed of light, all within the laws of physics. Now, let me stick my neck out. Everything I've said so far is well within the laws of physics. I'm a physicist, I know this. Now let me say something that is a little bit beyond that. I think this already exists. I think aliens in outer space already have mastered the art of laser porting, and that's what they do with themselves. They digitize their consciousness, shoot their consciousness throughout the galaxy, and there could be a highway right next to the Earth. There could be a highway of millions of souls being laser ported across the universe, and we are so stupid, we're so primitive that we don't even know it.
With all of this knowledge, sir, with all of this thinking that you have, are you an optimist still?
Oh yeah, no. Just remember, as General Eisenhower once said, pessimists do not win wars. Pessimists do not make history. Only the optimists win wars. Only the optimists win history. We are the makers of history.
We are living in an extremely optimistic nation where we want to go to Mars, where we want to do amazing things, and we are in a lovely environment here where young people have great ideas, and they are percolating these ideas to bring about a real change and make a difference. Professor, absolute honor. Thank you very much indeed. Thank you, sir. Thank you.